Alright guys, hey there and welcome back. We are on lesson 1.4 and we're going to be talking about the distributive property today and also evaluating expressions. Alright, so let's start with our first examples. We have simplify using the distributive property. Okay, so you notice these arrows right here are telling us that the 6 has to go to x and the 6 also has to be multiplied to -3. So just make sure whatever is outside is being multiplied by whatever terms are inside those parentheses. So what we really have is 6 times x, if my pen will act right. And we have 6 times -3. So that's plus 6 times -3. Okay, so then we can go ahead and multiply that out. 6 times x gives us 6x. And 6 times -3 gives us -18. So minus 18. Okay, so 6x minus 18. That is your answer. All right, let's move on to the next one. Once again, -3 is being multiplied by each term, so 2x squared, 3x, and -5. So those are what we're looking at. So we have -3 times 2x squared always take the positive or negative that's in front of this outside number. So notice here we kept a positive right here. And so with the -3, we're going to go minus. So minus 3 times 3x minus 3 times -5. All right, so that -3 times 2x squared, that's going to give us -6x squared. -3 times 3x, -9x. And -3 times -5 gives us positive 15. All right, so keeping that in mind, let's go ahead and work a couple from example 1. All right, so we have -2 times 5 plus x. So we have -2 times 5 minus 2 times x. All right, so -2 times 5, that's going to give us -10. And then -2 times x is going to be minus 2x. All right, and we want that variable listed first. So we're going to have -2x minus 10 for our final answer. All right, don't let B throw you off. Just because this -3 is on the right side instead of the left, it's still being multiplied to both terms. Okay, so -3 times 6, that's going to give us -18. And -3 times -x, that's going to give us a positive, right? Negative times negative. And 3x. And once again, we want that term first. So we have 3x minus 18. All right. Moving on to C, we have 8 times x squared minus 3x plus 5. So biggest thing here is just making sure we're distributing it to each individual term, okay? So 8 times x squared, that's going to give us 8x squared. Eight times -3x, -24x. And then 8 times 5 gives us positive 40. Okay, and this one actually has already got our terms listed the correct way. We want x squared first, then x, then no variable at all. And then lastly, we have d 1/2 going multiplied by 4x and times -8. So 1/2 times 4x. Okay, anytime you multiply by 1/2 of something, it's going to be cut in half. So we're left with 2x. And 1/2 times -8 gives us -4. Once again, that x variable is where it's supposed to be, so that is our final answer. All right, so we have previously talked about the distributive property and the multiplication property of -1. So remember, anything times -1, okay, is going to give you the opposite. But it's still important here that we're distributing it out. So -1 is going to go to 2x, and -1 is also going to go to 5. So let's do a couple of those. When this negative is on the outside, right, that's what it's showing us in this example. This negative, we know, is saying -1, right? That's where this is coming from over here. So with A and B, when we have this negative on the outside, we're multiplying by -1. So it's just going to make everything the opposite. Whether it's positive or negative, it will become the opposite, right? That's how the multiplication property works. So negative times 5x gives us -5x. And then negative times -3 gives us +3. And if this confuses you right here, remember it's -1. So -5x plus 3 is our answer there. All right, then we've got negative times -x plus 4. So negative times -x is going to give us a +x. And negative times +4 is going to give us an opposite, which would be -4. So if you look right here, we started with +5x minus 3, and all it did was flip those signs. So one's negative now and one's positive. Same thing here. We had -x plus 4, and because of this property of -1, it became the opposite. So positive and negative. All right, example 3 wants us to simplify using the distributive property and combining like terms. So we just talked about combining like terms. Now we're going to add that in with the distributive property. So before we do anything else and combine any terms, we want to distribute everything out. Okay, so 2 is going to go across, and 3 is going to go across. Make sure you go into all of the terms. So 2 times 3h gives us 6h. 2 times 3 gives us +6. 3 times h gives us 3h. And 3 times -7 gives us -21. Now we can combine like terms. So we have 6h that's going to be combined with 3h. Remember, those variables and exponents have to be exactly the same. And we have 6 that can be combined with -21. So 6h plus 3h is going to give us 9h. And 6 minus 21 is going to give us 15, -15. So 9h minus 15. Right? And for B, we're going to do the same exact thing. -5 times n. That's going to give us -5n. And then we have -5 times -6. That's going to give us +30. Six times 5, also +30. And then 6 times -3n will be -18n. All right, so now let's go ahead and look for our like terms. So we have -5n. That can be combined with -18n. And we also have 30 and 30. All right, so we have -5n and -18n. Remember, our variables are going to be listed first. So we'll have -23n. And 30 plus 30 will give us 60. All right, let's look at our last example, example C. Okay, don't let the fact that this has 3 terms throw you off. We're just going to still take it to each one. If if my pen would act right. All right, so negative 2 times 3 gives us negative 6. Negative 2 times negative 4s gives us positive 8s. And negative 2 times 7t gives us negative 14t. Okay, and then we'll just bring our other terms down. These are not just being distributed, okay? All right, now let's highlight some like terms. So we have 6. That can go with nothing, okay? So then we have 8s. And we have negative 3s. And then we have negative 14t. And positive 2t. So let's go ahead and start with our variables. And notice we have s and t, so we want to put that in alphabetical order. So we're going to start with s. We have 8s minus 3s. That's going to give us 5s. Then we have negative 14t plus 2t. That's going to give us negative 12t. And then we're left with negative 6. All right, then at the very bottom of the page, we've got simplify the area of a rectangle using the distributive property. So if you're not sure and you don't remember what what the formula is for the area, our area is going to be length times width. Get very comfortable with that formula. We'll use it a lot from here on out. Okay, so we have our length on A, 5x minus 2, and we have our width of 4. So we're going to take our 4 and we're going to multiply it times 5x minus 2. So 4 times 5x minus 2. We just have to multiply the length and the width. And we're going to distribute that 4 across. So 4 times 5x gives us 20x. And 4 times negative 2 gives us negative 8. So 20x minus 8. All right, now let's look at B. So we still want to do the same thing, length times width. So we're going to do 15 times x minus 5. Right, and you could write it either way. Just think back to that problem we solved earlier. So if you had x minus 5, you could still say times 15. Oh. But you would just be then distributing it backwards. All right, so we have 15 times x. That gives us 15x. And 15 times negative 5 is negative 75. So 15x minus 75. All right, we'll go ahead and move to the next page. If you haven't already, you can print these notes off and make sure you're following along if you are watching the video. So now we're going to talk about evaluating expressions, okay? So there's a process to this. When we want to evaluate an expression, that means we've got variables in there and we want now to have some sort of value for them. So the first thing we're going to do, replace our variables with parentheses. I'll go ahead and show you over here. So notice they've got those x's highlighted, written in red. They have now changed that x out, that variable, out for parentheses, okay? Because we know we're going to be plugging something in. All right, and what we're going to plug in, back over here to our second rule, substitute the given values for the parentheses. Okay, so our given value was x equals negative 3. We plug in negative 3 wherever we've put our parentheses, and then we'll use our order of operations to solve it. Okay, remember GEMDAS instead of PEMDAS because we want groups, not just parentheses. So we have 2 times 9, that gave us 18. 7 plus 3, that gave us 10. And then our final answer was 28. So let's work a few of these. So it says, example 5, evaluate each expression for m equals 4. Let's highlight in different colors. N equals negative 11. P equals 2. And Q equals negative 5. So anytime we see those numbers, let's circle it. So we have M in pink. So I'm just looking for all of my M's so that I know where I'm plugging in 4 anytime I see that M. And then we said N, so looking for all of my N's. This will just help you stay organized in the long run. Obviously a step you don't have to take. We gave Q negative 5. Let's look for Q with green. And then we have P for 2. Oh, there's a Q, of course. All right. Anywhere we have a P, I'm going to underline that as well. All right, so let's go ahead and start filling these in. So if we have 8 plus N, we look up here, we have N equals negative 11. So we're going to plug in negative 11 for N. So 8 plus negative 11. Okay, that plus minus is going to say 8 minus 11, and we get negative 3. T minus Q. Q is negative 5. So 10 minus negative 5. That's going to be 10 plus 5. So we have 15. 3M, we said M equals 4. So we have 3 times 4. And that's going to give us 12. D, we have 24 minus 4Q. Our Q is negative 5. So we're going to have 24 minus, okay, notice that it says 4Q. So we're going to say minus 4 times negative 5. Okay, so we need to distribute this out first. So then we have 24. Negative 4 times negative 5 is going to give us positive 20. So we have 24 plus 20, which is going to give us 44. All right, N squared. N is equal to negative 11. So we're going to have negative 11 squared. Remember that that is saying negative 11 times negative 11, okay? I don't have much room, but... So negative 11 times negative 11, it's not negative 11 times 2. It's going to be 121. All right, F, we have 5M over 2. So we're going to say 5 times 4. Over 2. We're going to multiply our numerator out first. So 5 times 4 gives us 20. So we have 20 over 2. 20 divided by 2 or simplified out, either way you say it, is going to give us 10. All right, we have N, which we're going to replace with negative 11. Plus 110 minus 2 times Q, which is negative 5. So the first thing we need to do is multiply that negative 2 times negative 5. So negative 2 times negative 5 gives us positive 10. Okay, and then those are all, I know that's kind of hard to see. Sorry, y'all, my pen is acting a little crazy. Negative 11 plus 110 plus 10. Okay, so you can start one way or the other. If you want to look out the outsides, negative 11 plus 10 is going to leave you with negative 1. So then you have 110 and negative 1. It's going to give you 109. Oh. All right, let's look at H. So we have mn plus p. So it's going to be m times n, which is going to be 4 times negative 11. Plus p, which is plus negative 2. So 4 times negative 11, that's going to give us negative 44. Plus negative 2 is going to... Wait, is that right? Plus... Oh, I don't know why I wrote negative. Plus 2. So negative 44 plus 2 gives us negative 42. All right, let's look at I. We have 2 times p plus q, but notice we've got some absolute value bars. So let's go ahead and plug in our information. So we have 2, the absolute value of p, which was 2, plus q, which is negative 5. So remember, we're using GEMDAS, so the grouping needs to be solved first. So everything inside those absolute value bars, that is a group. That's why we changed it to G instead of P, so that you're not just looking for parentheses. So we have 2 plus negative 5. That's going to be 2 minus 5. So we have 2 times Okay, we're going to solve that 2 minus 5 first. So we have 2 times the absolute, oh my gosh, 2 times the absolute value of 3. This is getting ridiculous. Okay, so 2 times the absolute value of negative 3. We know the absolute value of negative 3 is 3. So 2 times 3, and our answer is 6. J, we have m plus 6 divided by p. So what we have is 4 plus 6 divided by 2. So the first thing we do is divide. Don't add that 4 plus 6 yet. Divide the 6 divided by 2. So that gives us 4 plus 3. And our answer is 7. All right, notice we have a negative on the outside and it's squared, so just be very careful with how you write this one. So we've got negative times m, which is 4, and times q, which is negative 5, and that whole thing is squared. Okay, so let's solve 4 times negative 5 first. So we have negative times negative 20 squared. So negative 20 squared is going to give us 400. So that negative still needs to stay on the outside right now. Remember, a negative times a negative, which we had negative 20 times negative 20, is going to give us a positive. That's where we got 400. And then if we're multiplying that negative 1 that we know is actually there times 400, our answer will be negative 400. MP minus 2Q over 2. So we have 4 times 2 minus 2 times Q, which is negative 5, over 2. Okay, so let's start with the outside. We have 4 times 2, that gives us 8. Then we'll do the numerator. 2 times negative 5 gives us negative 10 over 2. So this is minus a negative, okay? Those are both supposed to be there. So then the next thing that we're going to do is divide, right? Remember to look at your fractions as division problems. So negative 10 divided by 2 is going to give us negative 5. So we have 8 minus negative 5, which is going to be 8 plus 5, and give us 13. Let's look at example 6. So now it says to evaluate each expression using the given values. Okay, so it's given us values just like we did in example 5, except they're different for each one. Okay, so a squared b minus b squared, where a equals 3 and b equals 4. Okay, so we've got 3 squared times 4 minus 4 squared. All right, so 3 squared gives us 9 times 4, and 4 squared gives us minus 16. Now we can multiply 9 times 4. That gives us 36. So we have 36 minus 16. And our answer will be 20. All right, notice b is the same expression, a squared b minus b squared, except our values are different. A equals 4 and b equals negative 7. So that's important that you understand that the values make a difference, okay? It's not the variables or the expression themselves. Okay, so we have 4 squared times negative 7 minus negative 7 squared. So 4 squared gives us 16. We'll keep that times negative 7. We'll bring down our minus symbol, and then negative 7 squared is 49. Okay, so then we can multiply 16 times negative 7, and we get negative 112 minus 49. So negative 112 minus 49 will give us negative 161. Next, we've got negative y squared minus 3xy, where x equals negative 4 and y equals 2. So we'll have negative 2 squared minus 3 times negative 4 times 2. Okay, so the first thing we're going to do is that 2 squared, so we're now going to have negative 4. Okay, the reason it's negative is because we're bringing that outside down. Then we can go ahead and multiply negative 3 times negative 4 will give us positive 12 times 2. Remember, we work left to right. So now we can say 12 times 2. That gives us negative 4 plus 24. And our answer will be 20 once again. Same expression, negative y squared minus 3xy, where x equals negative 5 and y equals negative 3. So this time we'll have negative 3 squared. See how that negative makes a difference? Because it is already there, but then also our y is negative. Minus 3 times negative 5 times negative 3. So let's start with that negative 3 squared. Once again, negative 3 times negative 3 is going to be 9, but we got to bring that negative down on the outside. So negative 9. Negative 3 times negative 5 gives us plus 15. And then we'll keep that times -3. So then we've got -9. 15 times -3 gives us -45. So then -9 minus 45 gives us -54. Let's look at E. We have a squared plus b squared over a minus b, where a is 3 and b is 4. So we're going to have 3 squared plus 4 squared over 3 minus 4. Okay, so 3 squared gives us 9. 4 squared gives us 16. Then we have 3 minus 4, that's going to give us -1. 9 plus 16 gives us 25. And we have -1. And we can divide that out. 25 divided by -1 gives us -25. All right, and then our last one says a squared plus b squared over a minus b, where a equals -3 and b equals -5. So then we've got -3 squared plus -5 squared over -3 minus -5. Okay, so -3 squared is 9. -5 squared is plus 25. And then -3 minus -5, that's -3 plus 5. That's going to give us 2. 9 plus 25 gives us 34. So then we can say 34 divided by 2. That will give us our answer, which is 17. All right, just 2 more. So example 7, A tells us to find the perimeter of the rectangle given x equals 3. Okay, remember that our perimeter formula is going to be 2L plus 2W. We want all of those sides added. Okay, so if x equals 3, we know we would have 2 times x plus 2. This is before I'm changing anything. Plus 2 times 7x plus 1. Okay, we're using that formula to fill it in. So then we can plug it in. So we have 2 times 3 plus 2 plus 2 times 7 times 3 plus 1. And then we'll work it out. So we can start by distributing. But before we can distribute, we need to solve what is in our parentheses. So 3 plus 2, that gives us 2 times 5. And then 7 times 3 is going to give us 21. Plus 1 is going to give us 22. So 2 times 22. All right. Don't have much room to work this out. So 2 times 5 is going to give us 10. 2 times 22 is going to give us 44. So then we have 10 plus 44, which gives us 54. So P equals 54. Make sure you're labeling it P equals. We need that to be labeled as the perimeter, because the next question is going to ask us to find the area. So remember, our area formula is area equals length times width. Okay, so our length times width. So we would have x plus 2 times 7x plus 1. Okay, and then we can go ahead and plug in our value of x, which is 5. So we have 5 plus 2 times 7 times 5 plus 1. So let's go ahead and work out what's inside the parentheses. 5 plus 2 is going to give us 7. Okay, then we have 7 times 5 plus 1. 7 times 5 is 35, plus 1 gives us 36, so 7 times 36. So our area is equal to 7 times 36, which is 252. All right, that is the end of our lesson, guys. If you have any questions at all, please reach out to your teacher. They will be more than happy to help you.